So let's take a look at unit vectors. First of all, what is a unit vector? Well, a unit vector is any vector that has a magnitude of 1, because that means it's 1 unit long. Now, it doesn't matter which direction it's pointing in. All that matters is that the magnitude of your vector is equal to 1. As a quick reminder, that vector with the absolute value sign around it, that means magnitude. So we're going to be using that a little bit as we go through here. So in order to find the unit vector, we need to figure out a vector in general. So let's take a look at a very, very simple vector. This vector right here points to the right. Let's go ahead and say that it points 3 units to the right. So in component form, this vector is 3, 0. Positive 3 means we move positive 3 units to the right. 0 means that we move up or down 0 to go from the initial point to the terminal point. So if I want to find a vector that has a magnitude of 1 that points in the exact same direction, I need to scale this vector down. So the first thing I need to do is figure out the magnitude of this vector. Well, because it's just pointing to the right 3 units, that makes it really easy. The magnitude of this vector is 3 units. Remember, magnitude is just a fancy word for length. So we're looking at a magnitude of 3 units. So I need to take this vector and I need to scale it down. How much do I need to scale it down? Well, in order to make it 1 unit long, I need to scale it down by a factor of 3. So I'm going to use some scalar multiplication to be able to get this vector to have a magnitude of 1. And once I do that scalar multiplication, the scalar multiplication is when you multiply this scalar number by each component. So I'm going to end up with 1, 0. So this new unit vector is a vector that points in the same direction as the original, so it still points to the right, but now it has a magnitude of 1 unit. And it turns out this is a very special vector. This is a very special unit vector. We use it so often in math that we gave it a name. We call it I hat, or sometimes a bold-faced I. Now it's really annoying to have to be able to scratch in this boldface, so that's why when we write just by ourselves, we tend to use I hat. If you're going to type it, you're tending to use boldface. But either way, that's a vector that points 1 to the right and 0 up or down. So let's take a look at another one. What if you've got a vector that goes up, let's say 5 units this time? Well, we're going to follow the same idea. The component form of this vector is 0 left or right and 5 up or down. Since it's a positive 5, we're going 5 up. Which, again, finding the magnitude, very, very simple when you're looking at just a straight up, down, left, or right line. So our magnitude is 5 units this time. In order to get that unit vector, we want to make sure we scale it down. This time, our magnitude is 5 units, so we want to scale it by a factor of 5. So we're going to do some scalar multiplication on that original vector by saying 1/5 times that vector will give me 0, 1. So there's my unit vector. And again, this is another very special vector in math. A vector that points 1 unit up is used so often that we gave it its own name as well. We call it J hat, or again, bold-faced J if you're going to type it on the computer, but again, pretty annoying if you have to go ahead and make it bold every time. So this vector is a vector that points 0 left or right and 1 up. So let's take a look at something that's not as simple. But before we do that, let's think about what we're doing. Because really, what we're doing is we're taking our vector. So if we're given some vector v, let's go ahead and put an arrow above it to show that this is a vector. If we're given some vector v, then we can make it into a unit vector by taking our vector v and dividing it by the magnitude of v. This is going to be that official formula to figure out a unit vector. You take the vector and you divide it by its magnitude. So let's look at an example that's not super nice. So here's a vector that points up and to the left. Let's go ahead and put its components in so that we can figure out a little bit more information about this. It's going to point to the left 4 units, and it's going to point up 3 units, which, using your ideas of Pythagorean triplets or going ahead and doing Pythagorean theorem, will tell you that the length or the magnitude of this vector is 5. So the magnitude of this vector is going to be 5 units. Now again, these are not drawn to scale, so while these should be the same length, they're probably not. I'm not using grid lines, I'm just kind of eyeballing it. So if I want to find the unit vector of this, then I need to take my vector, my original vector. So the component form of that vector is going to be 4 to the left, so -4, and 3 up. So here's my original vector. I need to divide it or multiply it by 1 over the magnitude of the vector. So the final unit vector is going to be -4 over 5, comma 3 over 5. And if you don't believe that this is the unit vector, then go ahead and use your Pythagorean theorem to figure out what the magnitude of this vector is. And I guarantee you it should come out to be 1. And if you go a step further, you can figure out the direction. If you figure out the direction of this yellow vector up here, and you figure out the direction of this vector here, they should be exactly the same. And that's what a unit vector is. It's a vector that points in the exact same direction as the original, but only has a magnitude of 1.